Okay, geographers, I'm going to go over your seventh lab. This one's on map scale, so we're getting back to mapping stuff. We did the climate stuff prior to this. Now we're going to be going back to some mapping stuff for this week, and next week we're going to get into some geology and plate tectonics. So, trying to keep this going along with what you're learning in the lecture class, assuming you're currently taking a lecture class with me. But every now and then we're going to go back to some of this just fundamental cartography map stuff. And that's what this is. And so with map scale, it's a pretty easy, straightforward concept. It's simply a ratio, right? Between how big something is in real life, out in reality, and then how big that thing is on the map, right? That's all it is. So we can't make a map with a scale of 1 to 1, meaning everything is real size. Actually, there's a short story about that. You can look that up and read about that if you want to. But for the most part, outside of Argentine literature, there is we don't do that. We shrink everything, right, so that it's manageable, so that we can put it on an actual piece of paper. So that's all map scale is, and that's like you said, it's pretty straightforward. But as you see, we'll work through it. It's good to be comfortable with this stuff. So throughout the lab here, what we have to start with, again, as I always say, read through this stuff. But as we start through here, it references that essential world atlas that you should hopefully have in your possession by now, and some specific maps. And it's simply asking, for this first political world map, what's the scale? And I'm going to get into and explain this scale right here, how to read this and what that means. But you should see this just written somewhere on that map. Copy it down right here, right? How wide in miles is the area shown on the map from east to west? Just measure across using, there should also be a graphic scale there. I think on all of these maps, if you don't see that, keep listening to what I'm talking about here, and I'll show you how to convert stuff in a moment. But you're simply saying it is this many miles from the eastern edge of the map to the western edge, right? And then this, what types of cities are shown. Please do not list every single city that's shown, which is something that students quite often do. I just want to know, is it only the major cities? Is it capital cities in general? Do you see small towns? And a way to think about this, like look at the Antelope Valley. Look at this, part of Southern California with which you are familiar, and see, do you see Lake Los Angeles written there? Do you see, Little Rock, Rosamond, Quartz Hill, Antelope Acres? Think of these tiny little communities, and do you see these on there? If not, then clearly the small towns are not included. Or do you only see some of these? Maybe Quartz Hill is there, but Lake LA isn't, or vice versa. That would be that some small towns are included, but not everything, right? I just want to get you to get a sense of what is, what is this map drawn at this scale? What is it actually showing me in terms of detail and the totality of what's being represented in this map? Yeah, that's the idea there. So you do have with map 1, map 2, map 3 on the next page here. Same process. And so just kind of go through this stuff. Answer this stuff. Should be pretty clear, but let me know if you have any issues with that. And I want to skip down here to what scale is to really get into it. I have here 3 different ways in which we often express the same scale. Okay, so we start with verbal, our verbal scale, and that's where we're talking like people talk, right? Something here, 1 inch is equivalent to 1 mile. And that's the like logically proper way. I've had professors who got so hung up on this stuff. What we usually say is 1 inch equals 1 mile. Okay? And these professors would go like, "That's impossible. How can an inch equal a mile?" They get hung up on words, um, which can be good at times, but for this, I mean, come on. So technically, we would say 1 inch represents, or 1 inch is equivalent to 1 mile, but it's an easy way for the average person to pick up a map, look at it, and say, okay, I know what an inch is. I can easily measure that or have a sense of it. And so anytime I measure an inch on this map, it's equivalent, it's the same as measuring 1 mile in reality, right? That works in our brain. So that's useful in the sense that we can think in this way. But there are other ways to do this. We have this graphic scale next, and so we would just have some kind of line, and these can look different depending on the map you use. I always like to just, for the maps I'm making, put in something very simple, not get too elaborate. In some other maps, you'll see very elaborate ones that are used for more navigational purposes, but just something like this, it's really clean, really simple. Now, the trick here, since we're doing this virtually, is that we need to, make some assumptions. If you had this stuff printed out in front of you and that printing was controlled, it might be obvious, but the idea is from 0 to 1 here, that's 1 inch. Okay, like actually on the sheet of paper. When these labs were put together, it actually worked in that way. Sometimes when you print the PDF, it might not be a perfect inch on your printout. Just go with it, right? Assume that this 0 to 1 here is an inch, and then this from 1 to 2 is another inch. So it's a way of saying 1 inch is equivalent to 1 mile, but it's this graphic version. All right, so it's an easy way to get the same idea of the scale, but this time we have this visual thing. And I don't know, if we were actually in the lab itself, we'd be working with this stuff, doing more hands-on stuff. We might not get to it, but this can be useful if you're trying to actually use the map to take some kind of measurement. You need to know how long it is from point A to point B. You need to measure this river or this road or whatever feature it is, right? This is where that can be actually quite useful. I can't remember what other labs you have. We might get into that. We might not. I don't know. We'll see. Okay, but again, same thing here. 1 inch is equivalent to 1 mile is the same thing as drawing this graphic scale, and for every inch on the figure, it's 1 mile. You follow? Hopefully you follow. All right, and then our final type here is what we call a fractional scale, or a representative fraction. And this one quite often is the scariest of the three, but it's also the most useful and versatile. And so we read this as 1, and then the 2 dots here, we say 2, as in TO. So it'd be 1, 2, 63,360. Okay? And keeping in mind that this is the exact same scale as this verbal scale and this graphic scale that we already saw. Okay? So all three of these things mean the same thing. All right? What this fractional scale is saying is 1 unit is equivalent to 63,360 of those same units, right? And this is cool. Like the unit thing means whatever. Inches, feet, centimeters, millimeters, whatever it might be. That's a great thing here. It works with any type of measurement. So if I measure 1 inch on this map, it's equivalent to 63,360 inches in reality, right? If I measure 1 centimeter on the map, it's equivalent to 63,360 centimeters in reality. So this is why it's more useful, is we can use any different system we want in there, right? So these three different ways are the ways in which we can express the scale of a map. Again, that ratio, how big is the thing in reality compared to how big is it drawn on the map? Okay, that's scale. Now, as you go through here, we're going to get into some conversions and actually working with this stuff. Now, questions 5 and 6. I mean, 5, honestly, I just gave to you. Um, if you're paying attention, I mean, just think about that for a moment based on what I just said. But let me say, with 5 and 6, yes, you can go to Google, right? And you could type in 1 mile equals how many inches, and you'll get an answer there. Hopefully, a correct answer. Yes, you can do that. But a lot of this stuff, you shouldn't need to do that, or maybe I should say, you shouldn't want to do that. Try to figure this stuff out on your own. Obviously, because we're doing this in a remote capacity, I can't control what it is you're doing as you do this. But think of it as like, sure, you could easily Google this stuff, get an answer, and be done with it and be well on your way to a perfect 10 points on this specific lab activity, right? Yay. But really you're not gaining anything here. Think of college, everything you're doing in here as practice for the real world. And I say the real world, not in a way to like be derogatory toward college and what it is I do, because to be honest with you, I don't want to ever leave college ever again. That's why I got this job. But when I say the real world, meaning like whatever it is you're trying to do after school, right? Whatever job you want, career you want, all of that stuff, you're practicing. It's not about like you're not at your job. It's a good chance your boss isn't gonna come in and say like quickly say like quick, how many feet in a mile, or whatever. I mean, maybe they would. Depends on the job, I guess. But the point is, it's not a case of you just memorizing facts. It's you learning to think critically and solve problems and all of that. And so if you're going through this stuff, and taking these online classes where you can easily do this, you're not really learning anything. And by the time you get done with school and let's say you do get hired in a place, if you get hired in a place, you're not going to impress your boss if you can't think, right? So I just say that I totally understand the temptation. You're not a geography major. You just got to get this done so you can move on and do whatever. But like try to think about some of these things. Use this as a way to exercise your brain so that when you get to that first job interview, once you've graduated, or even like, with student employment and stuff like that, and once you get in the job, your brain's ready to go. That's why people hire college graduates. It's the thought that you can think about things and solve problems and all that in whatever the field is, right? So do yourself a favor and get prepared for that. There's nothing sadder than getting through school and trying to go get a job and you just can't get a job because you did the bare minimum in those first 4 years of school, right? And I say that not to be mean. I say that as a guy who did the bare minimum in the it was actually 5 years of school. Had that bachelor's degree and realized, oh my God, I didn't really learn as much as I should have. I can't compete in the job market. And that's why I had to go back to school and all that. So I simply say this to get you guys thinking about making the most of this time. Okay, pep talk over. With that. All right, so then as you continue through the lab, you're going to see you have two of these. Yeah, here's the first one. So we've got a column for the fractional scale, verbal, and graphic. All you need to do here, it's like this first one, you're given the fractional scale, 1 to 100,000. Remember, that's units. And this first one, we're dealing with inches and miles. Okay, so this means 1 inch is equivalent to 100,000 inches. Okay, the verbal scale, you can't write 1 inch equals 100,000 inches because honestly, that makes no sense. Like if I told you, hey, go run 100,000 inches. Would you even know what that means? Would you know if that's a good thing or a bad thing or when to stop? No, we don't think in terms of inches. For a verbal scale, we want it in bigger units. So we want 1 inch equals however many miles are in 100,000 inches. Right? That's all we're asking for right here. So think about what do you need to do, and maybe questions 5 and 6 have helped you, and all this previous stuff have helped you figure it out. But do what you need to do mathematically to figure out how many miles are in 100,000 inches. And I'll let you know it's not a pretty number. So when you get a decimal, don't panic with this stuff. Okay. And then the graphic scale is simply what you're going to do is draw something like this down here. And again, assume it's 1 inch between 0 and 25, and 25 and 50. Going to do the same thing, but you're going to have different numbers. It's not going to be 25 and 50. It's going to be whatever this number is, right? There you go. This next one, you're going to work backwards in the same. I mean, you can draw the graphic scale the same way, but figure out how many inches are in 4 miles, and that's your answer there, right? And so on. So fill in these missing spaces, okay? Same thing down here, kind of the same idea, just in word problem format. So read through here. You've got all the information you need to calculate what's the fractional, what's the verbal, what's the graphic scale. Okay, so that's 8 and 9 and 10 and 11. Right here, we shift to the metric system, which is honestly, it's so much easier to use. But we don't use it here in this country for a variety of reasons. But you just, some simple stuff to make sure we're all on the same page. So this is that conversion stuff. And this, honestly, like with some of it, I have the appendix at the end to help with some of that. You can use the Google thing, but like try to look for the patterns. That's the thing with the metric system. It's so easy to convert between this stuff because it's all based on increments of 10 as we're going through here, and the names actually mean something and all that. So look for those patterns to make your life easier. Okay, with this stuff here, 17 and 18. Don't immediately Google it. Again, think about set up the problem first, and then once you know what's going on, you Google away. But again, exercise that brain. All right, 19. You're going to take. We've got our fractional, our verbal, our graphic scale. Now this time, whenever we're doing this stuff in metric stuff, assume, even if your printout doesn't show it, that it's 1 centimeter from 0 to 50, 50 to 100, 100 to 150, and all that, right? So we've got this. I want you to give me the equivalent. So it's going to still be 1 to 5 million over here, but do it 1 inch equals however many miles are in 5 million inches, right? And your graphic scale will be 0 to whatever that number is, and it'll be an inch in between there, right? So do the same thing, but do it for the American system, the imperial system, okay? And think about it, because there's some ways which you might immediately, again, this is why I warn about this stuff. You might just go to Google, type in some of this stuff, try to do some simple conversion. You're going to get a wrong answer, right? Make sure you're thinking about this. What should that answer be? Okay, just think. All right, here's our next little graph thing here. Same concept. You can even see this is 1 to 100,000 again, but you're going to do it 1 centimeter equals however many kilometers are in 100,000 centimeters. Okay, and just spoiler alert, it should not be an ugly number. It should be a beautiful number. Again, to show just how nice this metric system is. And then here, like I said, from 0 to 10, assume that's 1 centimeter, whether it shows that on your printout or not. Okay, this is an aerial scale. This next one, you're going to look through here. It doesn't even really matter what the map itself is about, but you need to find the land designated 6.3. Okay, so look around this whole thing. You have all these number designations. Look for that land that has that 6.3 designation. And then using these little scales down here, we've got this square is equivalent to 10 acres. This one is 5. This one is 1. Okay, so based on that, try to figure out what the acreage is, right? Which is an actual length times width kind of. That's what we mean by aerial scale. We want to know how big a piece of land is or property or whatever. Do your best. Find out how many acres that the area that 6.3 is on the map. And don't kill yourself. I don't expect you guys to get, little calipers out and things to get it down to, 0.01 acre, whatever. Just, eyeball the thing as best you can. Okay? Don't stress over this one. And then finally at the end, you're going to find treasure. So with this, it's the idea you got this treasure map, you got the X, and X marks the spot. We know where the treasure is, but we actually don't know, is it in the center of the X or in the upper, right corner or lower right corner or whatever. So what you're going to calculate is how much area does the X on the map actually cover, okay? And we're going to start with a scale of 1 to 5,000, okay? And we're going to assume that each side of the X covers 1/8 of an inch, okay? So with 1 to 5,000, we take you through step by step to know what you have to do, okay? And so you get that answer, how many square feet that X actually covers if the map is that scaled. Then you're going to do the same thing, but let's change the scale. Let's see how that changes. So instead of 5,000, we're going to do 1 to 10,000. So like we did up here, and you don't need, leave all this stuff as it is, but go through that same process, instead of 5,000, plug in 10,000 anytime here, right? Put your answer there. Then do 24,000, 100,000, and so on. Okay, just to get a sense of how important scale is when it comes to accuracy on a map and generalization and some of these other concepts. All right, does that sound good, geographers? You got this. I believe in you. I believe. Just remember, work that brain, exercise it. You guys will be fine. All right, best of luck.